Okay, so let's look at this example. F of x equals 3x over x minus 2. First thing we have to do, because it's a rational function, is find all of our asymptotes and holes if we have any. We can look at this and tell, because the powers are the same on top and bottom, that the horizontal asymptote occurs where? At y equals 3, the quotient of the coefficients. And then nothing will factor and nothing will cancel. So I know I don't have any holes, but I do have a vertical asymptote at the restriction x equals 2. So those are my only asymptotes. Got it? I'm going to go ahead and put those on the graph. Y equals 3. And x equals 2. So this is much easier than the previous example, because instead of dividing the graph into 3 sections, it just divides it into 2, a left and a right section, which I really prefer. It's the middle section where weird things can happen. On these outer edges, we know that it can either hug in this upper quadrant or the lower here. How do I figure out which? Just make a table. We make a table for each piece. So for my left piece, I say we try, and it's really good to get close to the asymptote, so I'm going to try to let x be 2.5, 1, and 0. And I'm going to see how that works. That's what I'm going to let it be. X equals 2.5, 1, and 0. If you substitute 2.5 into there for x, what y value do you get? How much?
15.
15. Okay, what happens if you put 1 in?
Negative 3.
Negative 3. Okay, you're going to have to tell me again. You're telling me that 2 point... Oh, guys, 2.5 is not on the left side of the asymptote. I am so sorry. I'm looking at it going, this doesn't make any sense. What should that be? Instead of 2.5, that should be 1.5. Thank you. I knew it was wrong because 1 was above and 1 was below, and I was like, this cannot work. I'm so sorry. 2.5 is on the right side. I want numbers to the left. So let's change that to 1.5. I need a do-over. If I put 1.5 there, what do we get?
Negative 9.
Negative 9. What if I put 1 in?
Negative 3.
What if I put 0 in?
0.
0. Okay, let's put those on and take a look. We have a dot at 0, 0. We have a dot at 1.5, negative 9, which is way down there, right? Yeah? Okay. We have one at 1 comma negative 3. I would like a couple more. Somebody tell me what negative 1 is.
1.
Positive 1? And then just to go really crazy, tell me negative 5.
15 over 7.
Okay, tell it to me as a decimal.
2.14.
So 2.1-ish. Let's put those on and see where we are. Negative 1, 1. Then when I hit negative 5, I'm at 2.1. So do you see, it's only now is it starting to get close to that asymptote up there?
It's really big.
It's, yeah, well sometimes they are. And then we just draw a little curve. Uh-oh, I missed, but you get the picture. Draw a curve indicating that it's going to start hugging the asymptotes. What's neat, you guys, is sometimes it hugs very closely and sometimes not nearly as close. So it's just, that's kind of why you do those, is you have to decide like how closely is it hugging. Now let's make a right-hand section. For the right section,
2.5.
well, let's start with 2.5. We already know 2.5 occurs way up at 15. How about 3? 9? 4?
6.
6? That's still really big. Is it 6? Okay, how, I don't know, give me 7.
4.2.
All right, close enough. 4.2. All right, let's put those on and see what's happening. 2.5 is way up at 15. 3 is way up at 9. 4 is at 6. Ugh. And 7 is at 4.2. So it's hugging, it's pretty far away. It's not hugging very closely through here. Do you guys see that? Okay, that's all it takes to graph those. Do you have any questions about that? All right, let's do another. Okay, so we want to graph y equals x squared plus x minus 2 divided by x minus 3. First thing I notice is that it doesn't have a horizontal asymptote. Second thing I notice is that the power of the top is 1 more than the bottom. Since it's 1 more than the bottom, I'm going to have to go find the slant asymptote. That's going to be kind of the hard part. So I'm going to save that for a minute and come back to that. To find the vertical asymptote, does that thing factor? Yes, it factors into x plus 2 and x minus 1 over x minus 3. Unfortunately, nothing cancels. So x equals 3 is a vertical asymptote. Okay, so now I need to come down here, and I need to find the slant asymptote. The slant asymptote is found before you factor. And I'm going to divide x squared plus x minus 2 by x minus 3. Okay, what do I multiply x by to equal x squared? 1x. And then we multiply x squared minus 3x. Draw a line, change your signs. So this will become minus, this will become plus. Tally them up. We get 4x minus 2 remaining. And you do it again to find the b. We know the mx, it's just 1x, right? Now we need b. What can I multiply 1x by to make it equal 4x? Positive 4. So positive 4x minus 12. Draw a line, change your signs. And that gives us a remainder of 10. But I ignore that, correct? So my slant asymptote is y equals 1x plus 4. Any questions on how we locate the asymptotes? Ask them now. Okay, then let's go put those asymptotes on the graph and see what it's going to look like. It's kind of neat. Well, the slant goes at y equals x plus 4, and we can graph that just from slope-intercept form. Put a dot here. Okay, so we put our dot at positive 4, and we have a slope of positive 1. There's your slant asymptote. I guess technically you could just leave it, as a bunch of dots. It's okay. It's an asymptote, so you put it as a dotted line. And then there also is an asymptote at x equals positive 3. Do you see how this makes kind of a crooked x? Yes? You still look at it as left of the vertical asymptote and right of the vertical asymptote. So over here to the left, our option is it can hug here. That did not work. Let's try this again. It can hug here, or it can hug here and follow this way. Those are the only two options for what that graph can look like there, just so your brain can start to process it. To figure out which, just go make a table, and you'll figure out how well it hugs. Is it okay if I erase this stuff? I'll take that as a yes.
Yes.
Okay. Ma'am?
Why don't you have an asymptote on the far side?
Because I'm only talking about the left side right now.
It does the green.
I haven't, we're just talking about it piece by piece. It's easier if you separate them into sections.
Okay.
So we're going to do the left section and then the right section, okay? All right, so we have a left section, and over there I want to know, so how about, I don't know, guys, pick something. Give me some X's and some Y's. I'll pick them myself. You ready? Let's do -3, 0, 1, and 2.5. -3, 0, 1, 2.5. Give me those. Take a minute. Go give me those Y values.
negative 3 is negative 0.666.
Negative point,
Six.
so negative 0.7-ish? Okay.
1 is 0.
Negative 0.7. What's 0?
0.667.
So positive 0.7. Hey, that was written in a strange place.
1 is 0.
1 is 0. And what's 2.5?
Negative 13.
Oh, too small for me to deal with. Okay, negative 13.5. Ah, but we get the picture. Okay, let's go drop those dots on and look at it. Negative 3 and negative 0.7. So about right there. So already we know it's doing this one, the green one, not the yellow one, correct? Okay, 0 is positive 0.7. Ooh, it doesn't hug as closely as I thought though. 1 is 0. And 2.5 is negative way down there. So it actually is doesn't hug as tightly as I had hoped, but you get the picture. It looks like that. Do y'all understand? So now if I wanted to, I could go back through and I could erase that highlighter. And I think I will do that just to make us feel better. Okay, nothing's working. Let me try that again. I was not a good colorer when I was a child. Okay. Is it okay if I leave the green though? You guys know it's not really there, right?
Yes.
Okay, now let's talk about the right piece. So the right piece is a little trickier. It either is going to live here or it's going to live in here, like that. So these make some pretty neat shapes, I think. So we have to go over there and figure out which one of those the right piece is doing. I'm going to pause for a second and let you take a minute to try to graph it yourself, okay? So which x values did you guys pick?
3.5.
All right, 3.5, so something just to the right. What'd you get when you put that in?
27.5.
27.5. I think we've established that it's in that upper section up there, right? Definitely not down here. 27.5. Tell me 4.
18.
Ooh. How about 6?
13.3.
13. That's really big. 13.3. What if I put in like, they're still going to stay pretty big. So, okay, so we've established they're all up in here, right? So we'll just stick a little thing up there and be done with it. And you can only sketch. Like when numbers get that big, it's mainly about just understanding. It's not about being perfect. So just throw them up in there, okay? Even though I'm not going to count out to 18 or 13.3. Is that fair? Okay, great. We only have one more example to get through, so we will break it right there.